Let's look at a couple examples here. Let's say that we are flipping a coin, all right? Remember, this is just a regular fair coin. Our sample space, which this is kind of sorry, this is a notation that we like to use. It's not something I'm going to require of you, all right? But this is us saying, hey, this is capital S for the sample space. And then we put these curly brackets to show what pieces are inside the set. This is our set notation. All right, so these curly brackets, which I can make a little more neat, are bounding all of the elements with commas separating them. So if I flip a coin, what's one possibility? Well, it could land on heads, or it could land on tails. All right, it can't land on anything else. Those are the only possibilities. Therefore, that's my entire sample space. If event A is landing on heads, then what is the probability of A? What is P of A? Well, let's ask ourselves, what's in event A? Okay, I know this one is a little redundant because it's such a small example, but event A is only the possibility of landing on heads because we defined it as landing on heads. Therefore, the probability of event A, or the probability of landing on heads, is 1 out of 2. Remember, that's the number of ways A can occur divided by the number of possible outcomes. This can also be written, if you want, as 0.5, or you could write it as 50%, okay? Fraction or decimal, but note here that that is between 0 and 1, so we know we're good to go. What if I roll a 6-sided dice? All right, just one time. I'm just rolling this dice a single time. Well, what is one of the possible outcomes? Yeah, we don't have to start at 1. We could write 3 first if we wanted, all right? But if you sat there and you thought about what you could possibly roll, your possibilities are 1, 2, 3, 4, 5, or 6. All right, note that there are 6 possible outcomes. If event B is landing on a 2, what's the probability of B? Right, well, event B is only landing on a 2. There's a single element in B. There's only one way that event B can happen, meaning that the probability of event B, or the probability that we land on a 2, is 1 out of 6. If you put that into a calculator and round to 4 decimals, you're going to get 0.1667. 4 decimals is just kind of usually safe if you're writing a probability as a decimal value or anything as a decimal value. What if we were looking at the probability of rolling an even number? Event C is what we're going to call this, rolling an even number. Well, out of my whole sample space, which ones meet that requirement? Which ones are even numbers? We have 2, we have 4, and we have 6. Those are the elements that are in event C. There are multiple ways this time that we could accomplish this task. There are 3 ways to accomplish event C. So the probability of rolling an even number, or the probability of event C occurring, is 3 out of 6, or 0.5. All right, finally, if event D is rolling a number greater than 4, ask yourself real quick, out of my sample space, what numbers are greater than 4? Well, the numbers greater than 4 are 5 and 6. It doesn't say 4 or greater, because then we could include 4. It's just the numbers strictly greater than 4. So 5 and 6. There are 2 ways for D to happen. So the probability of D occurring, or the probability of rolling a number greater than 4, is 2 out of 6, or 1 out of 3, or 0.3333, repeating.